Welcome everybody. I have to stay close to the microphone. I'm not wearing a radio microphone, unfortunately. We are recording this session for the benefit of those who are not here today, this afternoon. Let me give you a bit of a background to the paper before I get into the software demonstration. This is a paper called Monitoring Transmission of Systemic Risk from Shadow Banking to the Regulated Banking Sector. I know probably not everybody's familiar with the phrase shadow banking, but shadow banking is basically those financial institutions that are not regulated by the authorities as closely as the normal banks are. So I'm talking about mutual fund groups, finance companies and the like. The importance of shadow banking is particularly during the global financial crisis of 7, 8 and 9, 2007 to 2009. They were used, in other words, the shadow banking institutions were used to securitize assets. That means taking, for example, a loan portfolio from the balance sheet of a bank, regular bank, removing it from the balance sheet and selling it as a different package assets to the potential investors. What that sort of led to was the banks were heavily borrowing in a way, but the level of borrowing was not reflected on their balance sheets. So they were getting away with generating a lot of products, but they were not required by the regulators to put in additional liquidity because it wasn't on their balance sheet. So that was the essence of the problem. So the bottom line is shadow banking is, as I said, they're intricately connected with the regulated banking sector. And we know that it is a source of what we call systemic risk. Now, the easiest way to describe systemic risk would be for you to think of it as what happens if a major bank like Commonwealth Bank of Australia were to fail in this country. Now, it's one of the 4 major banks in Australia. If Commonwealth Bank were to fail, the chances are a lot of other banking as well as shadow banking institutions would be adversely affected as a result, because we live in a very interconnected economy, and not just locally but globally as well. So when such a failure happens and it gets transmitted to all the other counterparties that are related to the institution in trouble, then we describe that as systemic risk. That's the essence of it. So really the essence of this study is to try and monitor, capture or explain by demonstrating PLS SEM for the first time in this field how we can capture the systemic risk coming from shadow banking and being reflected in the regulated banking sector. That's the core of the study. That's just a bit of a background.
Thank you. Would you have an example of a shadow banking organization operating in Australia at the moment?
We don't have too many of them here. Right? We don't have too many of them here. They're more widespread in USA and Europe. Shadow banking is tiny in this country, mainly because of APRA's regulatory efforts. So I don't really have a name off the top of my head right now, but it's very small, I know that much. Now the core hypothesis that we're going to test using partial least squares structural equation modeling, and I'm assuming that's why you're all here to learn about PLS SEM. The first, or the core hypothesis, is systemic risk in shadow banking makes a significant contribution to systemic risk in the regulated banking sector. And there are 2 sub-hypotheses to that, where we look at micro-level or microprudential level linkages coming from shadow banking into the regulated banking sector. That's H1A. And H1B looks at the micro-level linkages. Okay, I'm getting to the chart, the figure, which will help you better understand where I'm leading with this. We start with 7 reflective indicators, and I'll explain this jargon in a moment, 7 reflective indicators and 10 formative indicators to begin with. Now, we couldn't find data in the public domain on the so-called formative indicators, so we ended up, in the paper anyway, we ended up simulating it. Okay, we didn't really have a choice. But the main purpose of the paper remains one of illustrating how PLS SEM can be applied in this field. So whatever conclusions we draw at the end, we're not saying they're concrete. They could change because once you get to real data as opposed to simulated data, the findings could easily change. So again, the purpose of the paper remains one of illustrating how PLS SEM can be used. Within the 10 formative indicators, we have 5 microprudential indicators and 5 macroprudential, so they're evenly split. And when we look at the data, what we see is it's non-normal in terms of its distribution. And we have a relatively small sample size of 63 US bank holding companies. Mind you, that 63 that we have in the sample accounts for about 83% of the total assets in the entire bank holding company population in USA. So it looks like a small sample, but in terms of the assets, it's about 83% of the total assets available. So it's quite representative is what I'm trying to say. But there are 2 other points that are important here for you guys to note. The data are non-normal distributed, in other words, skewness and kurtosis, and relatively small sample. This is 2 of the attractive features of PLS SEM. In other words, PLS SEM works reasonably well if you have a relatively small sample to begin with, as well as if you have non-normal data. Now, in real life, we all know this. Anyone who does research knows this. It's quite difficult to get normally distributed data. Very difficult to find normally distributed data. So if you were doing more traditional structural equation modeling, that's known as covariance-based, and you guys are in the same class as I am, covariance-based SEM. One of the assumptions behind that traditional structural equation modeling is that your data is or are normally distributed. So we are waiving that expectation here. Here we go. These are the indicators. On the left-hand side, we have the simulated formative indicators. The 5 for micro, 5 for macro level linkages. And on the right-hand side, we have the so-called, to begin with anyway, 7 reflective indicators. Now, in a moment, you'll see that when I run the initial testing, those 3 with the yellow, I should point with the mouse, those 3 with the yellow fonts underneath it, removed following initial testing, they do drop out because of very low loadings. Okay? We'll see this shortly. So 10 formative and 7 reflective indicators. In terms of continuing with the introduction to PLS SEM now, I'm leaving the paper sort of behind at the moment and moving towards PLS SEM. The idea is to set up a predictive model. What are we trying to predict? We're trying to predict the level of systemic risk in the regulated banking sector that can be explained by the shadow banking linkages, micro and macro linkages coming from shadow banking. That's what we're trying to explain. Now, ultimately, we'd love to see a very high coefficient of determination, R squared if you like. And if you don't mind me jumping to the conclusion here, we end up finding 75% R squared in the end. But bear in mind, half the data are simulated. So we can't sort of project that finding to the real world at this stage of the paper. Okay, so this slide talks about the nature of formative versus reflective indicators. Let me give you guys a non-financial example. And I'm borrowing the example that was given by Professor Christian Ringel, the German professor, who is one of the co-authors of the paper. How many of you attended Christian's presentation early last December? One person did. Okay, he came here with one of his colleagues. What's his name? Mark or something like that, Marcus. And they gave a demo of PLS SEM. And Terry and I were there, and I really got hooked onto this. I mean, one of the things that I like about this method is, my background is non-parametric. I specialize in data envelopment analysis, DEA. And I was looking for a new non-parametric technique that I can apply to my research. And when I sat through Christian's workshop early last December, I thought, this is it. I want to learn more about this. And I am still a student, okay? So go easy with the questions. I don't know anything in-depth as such. What I know is I've already summarized the rules of thumb, the guidelines, the key variables and numbers to look out for in the attached documents to the emails. Other than that, I don't really know the full statistics behind it. But I've also given you guys a list of references that you can have a look at to get more in-depth information. Okay, formative indicators are regarded as complementary, and reflective indicators are regarded as interchangeable. What do I mean by that? The example that Christian gave last December was drunkenness. It's something that is latent. It's not something that you can measure by a single metric. You can't, you can see the behavior of a drunken person and you can reach the conclusion that the person is drunk. But let's have a look at the reflective indicators which we are claiming to be interchangeable in this context of drunkenness. If I say to you, one of the reflective indicators I would use to understand drunkenness is whether the person is able to walk in a straight line. Yeah? Another potential reflective indicator would be if the person is slurring in his speech, or maybe there's blurred vision. Okay, all of these 2 or 3 indicators are just given for drunkenness, which is a latent construct, are reflective in the sense that they reflect the state of being drunk. And they're interchangeable. So if someone is unable to walk in a straight line, there's a good chance that their speech is going to be slurred as well. Yeah? So they're interchangeable. That's what we mean by interchangeable. Which means you would expect those indicators to be highly correlated. That's the natural expectation. Okay, how about on the formative side? Well, if I take the same concept, drunkenness, and set it up as a formative construct, latent construct, then I have to come up with different indicators. The amount of wine consumed by the person, the amount of vodka consumed by the person, the amount of scotch consumed by the person. These are examples of formative indicators that will, in a way, determine drunkenness, have an impact on drunkenness. Okay, here it is, the figure that I've been promising for the last 5 minutes. This is an illustrative chart, as I indicated in the title. We have a real chart reflecting the model later on, actual model, but the concepts are the same. So we have on the left-hand side so-called formative indicators, and on the right-hand side we have the reflective indicators. think about the example that I've given about drunkenness. So we have in the middle the so-called structural model, 3 ellipses or circles. We have 2 essentially exogenous constructs or independent variables explaining one endogenous or dependent latent construct. Okay, so we've got 2 constructs. One is based on micro-level linkages. The other one is based on macro-level linkages, and these are to do with the shadow banking sector. And the idea is to figure out to what extent these 2 exogenous constructs will explain the variation that we're observing in the endogenous construct, which is the systemic risk in the regulated banking sector. Does anyone have any questions at this point about the model that we're setting up? Yes, please.
Just to use your example again, so the top one might be the amount of alcohol you drink, and the bottom one might be lack of food. Would that be correct?
Yes. 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 Yeah. Yeah.
One more question. In the context of what we are doing at the moment in structural equation modeling, why would we need PLS SEM for this, I would say, model? Because I assume this could be solved with SEM methods and techniques as well.
Well, the justification is, first of all, me wanting to learn PLS SEM, but the main justification is data are non-normal.
Okay.
Well, that's what I said at the beginning.
Yeah.
So distribution is non-normal.
Yeah.
Secondly, small sample size. Sample size of 63 is not going to work well with covariance-based SEM.
Yeah.
Remember, Ravi says at least 200.
At least 200.
Yeah. So we don't have that.
What my assumption was that possibly we have to have very complex models when we're using PLS SEM. So
it's true to say that PLS SEM does accommodate complex models, and this is not a complex model.
Yeah.
Okay. PLS SEM does accommodate complex models, but it's not a requirement of using PLS SEM.
Okay, fair enough.
Okay? Right. So one more time, guys. What we see in the middle, the 3 constructs, or latent constructs, is known as the structural model or the inner model. On the left-hand side, we have the formative indicators. In this illustrative example, we have X1 and X2 defining the micro-level linkages, X3 to X5 defining the macro level, and we have from X6 to X10 being explained by the endogenous construct. In other words, I'm asking you guys to pay attention to the arrowheads. Okay? So with the formative, it's the indicator explaining the construct. On the reflective side of the outer model, it's the construct explaining the indicator. So the causality is reversed. Okay? That's an important point. So in terms of these 2 guys here, the bold arrows, this basically says what are the path coefficients, P1 and P2 are path coefficients, and to what extent can we explain the variation in the systemic risk in the regulated banking sector by looking at the linkages coming from shadow banking. Okay? So we're hoping to find some significant P1 and P2 down the road. Otherwise, the R squared is not going to be high. Okay, that's the sort of the model. Any further questions at this stage? Okay, like I said, the first attempt is based on the 10 formative indicators and 7 reflective indicators. It turns out that SmartPLS sort of converges in 36 iterations, which is pretty good. If it was having any trouble in analyzing the data, it would have taken many more iterations than 36. So that's a good number to begin with, although we have some problems, as you'll see in a moment. So the initial testing suggests that removing 3 of the reflective indicators could actually improve the predictive model. The idea, the overall idea is to come up with a parsimonious model, right, with a reasonably substantial or high R-squared value at the end. So you'll see in a moment that 3 of the reflective indicators are not loading highly on this construct, okay? Which means we're going to consider dropping them at some stage. In fact, we do drop them. This is a summary slide as to what happens in the next 4 or 5 slides. We do drop them one by one, and every time we remove one of those low loading indicators, reflective indicators, what we see is an improvement in the statistical criteria. And that's what you're looking for. So there's a bit of experimentation. There's a bit of experimentation here. Here we go. This is the initial test with 10 formative and 7 reflective indicators. And there's a reminder to me to start the SmartPLS demo. Oh, music as well. Forgot to shut that one down. Here we go. This is sort of your blank canvas in SmartPLS. I'm going to take you guys through the steps of the demo outline. If anybody, like I said, forgot to bring a copy, Terry has some hard copies there. So we'll just follow those steps together. Now the first step says make sure data are saved in a CSV file. So that's the only type of file this software package reads, where the variables are grouped in a way that would reflect the theorized latent constructs. In other words, try to group the reflective indicators and the formative indicators in sequence. You'll see in a moment how helpful that's going to be. Rather than doing it randomly, give it some order. That's the first point. Okay, the second point says click on New Project. Now, let's do that together. And give it a name. That's SmartPLS Demo, TSR, that's Transmissional Systemic Risk. Just click OK. Now the next step says right-click on project name and import data file. So here's the project name I've just created. Right-click on that. Import data file. Oh, there's Terry's name there. There's my CSV data file. I'm just going to say open. We can probably leave that name as it is. I don't think it's going to clash with anything. Here we go. Okay, that's the data essentially. So RI stands for the first 2 letters, is reflective indicator, and FI for formative indicators. So I've got 7 reflective indicators and 10 formative indicators. Okay, so they're grouped together. That's going to help me tremendously. And within the 10 formative indicators, remember we have the micro linkages and the macro, and they're also grouped within themselves. So first we have the micro, 5 micro, followed by the 5 macro. If you can sort of give it an order, something like this, it's going to help you a lot. Just going back to the instruction sheet, it says click on the project name to return to the canvas where you can draw the model. Let's do that. Okay, here's the canvas. From the indicator list on the left, in other words, now we can see the indicators down here. Drag to the right of the screen the variables you want to be associated with each latent construct. Remember, we have 3 latent constructs, 2 on the formative side and 1 on the reflective side. Doesn't matter how you start, because my data is already in the right order. So if I go and highlight those 7 reflective indicators and drag them across. I'm having difficulty working with this tiny screen, but bear with me please. It's going to look like this. One of the, I guess, conventions we follow in PLS SEM is you move from left to right in terms of setting up the model. In other words, you put the formative model on the left and the reflective model on the right. I happen to start with the reflective model here, which I'm trying to keep on the right hand side, but the arrows are sort of pointing in the wrong direction. It's going to be messy if I leave it like that. So what I can do is I can right click on the circle, on the construct, and go down to where it says align selected elements right. Didn't work. Do it again. Okay, we'll do it in a moment. I don't know why it didn't work. No, it's not normally done here, not from the indicators.
No, from that one there was an option. Yeah. That.
Did I select the wrong one? Okay, thank you guys. Okay, so this is basically how it should be set up. This is the right-hand side, the reflective model, if you like. Now, I'm going to go back to the list of formative indicators and focus on the micro. And there's 5 of them. Drag it across to the canvas. Go back and pick up the remaining 5 macros. So you can see it's quite user-friendly once you get the hang of it.
So the default of the arrow goes basically that way. And then you just change which direction you want it.
Yeah. I mean, the issue is, by default, these models are set up as reflective. Okay, so now, as you pointed out, Andre, we have to change the direction of these arrows. So let's try and do that. Change mode of measurement model. Now it's formative. Do the same here. Okay, now at least at this moment, the arrows are all pointing in the right direction. What we need to do is now connect the latent constructs. That's easy as well. You go click on the connect. Okay, so this is the model, right? This is pretty much the model. Now at this stage, it's useful to change these default names. So we hit rename. Let's call it micro shadow banking. Macro shadow banking. Remember, these two are the exogenous constructs, and renaming this one, the third one, the endogenous construct, that's in the regulated banking sector. Let's just call it regulated banking sector. But one more time, what we're trying to figure out is the transmission of systemic risk from the shadow banking, which is split in this model into 2 constructs, to the regulated banking sector. I wish I had a bit more space on the screen, but let me try a bit of rearrangement, because at the moment you can't even see the full names of the variables. Unfortunately, there's no automation that I know of to expand the window to fit the variable name, so you have to do this manually. I won't bother on the formative side for the moment. Any questions at this stage, guys? You all happy with this? Okay. Let me see if we missed anything on the outline here.
Can I ask a quick question?
Yes, please.
Simulated data, what do you mean? Do you mean you draw them from a normal distribution, or what I don't know what it means.
there is a whole appendix in the paper that explains the simulation. It's quite sophisticated approach, actually. What we did was we started with the reflective indicators, which are observed data, actual observed data, and work backwards to the shadow banking. So take a bank, look at where the bank stands on these reflective indicators in terms of its systemic risk level, and then work backwards to create the data, to simulate the data for the formative indicators. That's what we did. Like I said at the very beginning, we don't know at this stage what the results will be if we had access to actual data, real-world data. So the purpose remains one of demonstrating how PLS SEM can be applied in this field. Okay. Did we miss anything on the instructions? Okay. Well, I think we're up to the calculation now. In terms of what I'm going to do next is I'm going to start running the calculations.
Before you start, do you have to sort of set error terms on those things, or it automatically does it?
Actually, I think the error is assumed away. Unlike covariance-based SEM, error is assumed away. Yeah, that's what I remember. Yeah.
Because of the assumptions, we're not using the same assumptions.
Yes, yes, yeah. Okay, guys, at this stage, we're ready to run the testing. I'm trying to get to the... How are we going to do this, Terry? I can't see half the screen.
Can you right click on the tab? Does that give you on the note? Drop back down again to where you had.
You want to come up here? You're the specialist.
Arr.
Oh, you need your glasses too.
Oh, absolutely. Okay.
You can close the slides if you like, if it's going to help.
Nope. So you're missing most of the...
I don't see any slider there. I know what you're trying to do, but I don't see any slider.
No, and you can't sort of increase the size of the window either. Shall I make that call? Copy, paste, import, sample, export. It's evil.
From calculate,
Sorry?
from the menu, calculate will it work?
Now that would probably be sensible. Calculate menu.
Use the menu instead of the icons. I guess we can try that. It's just that we're all used to icons. Anyway, okay. PLS algorithm is essentially the core set of calculations. Let's see how well this will work. Okay, you don't need to change the default settings here. I wouldn't worry about those. Just go start calculation. And right away you have the results under 5 seconds. And here is the figure again on our canvas, but with the numbers. Okay? So that's the R squared, about 80%, with 10 formative indicators and 7 reflective indicators. These are the path coefficients, in other words, to what extent micro is important in explaining the endogenous construct here as opposed to macro. So micro appears to be more important. And these are all the individual loadings for different variables. Now, if we look at this carefully, we can see that this one is very low, 0.067. So that's a candidate for deletion. Remember, we're trying to set up a parsimonious model. This one is, again, this one is quite low too. Okay. The total regulatory capital ratio. And non-interest income ratio is, again, under 5.5. That's quite low too. So I can see 3 reflective indicators there that are candidates for removal from the model. Okay? Now, you'll see later on that when we remove those 3, practically every statistical criteria improves, but the R-square drops to 75%. But I'm not worried about that. Okay?
Does it mean that there's a high collinearity? That the R-square is very high?
The way I understand R-squared is R-squared does rise if you have a larger number of variables in the model to begin with.
Either they are collinear even.
Yeah. So again, like I said, I'm not too concerned about a 5% drop in the R-squared because all the other more important statistical criteria are improving in the process of removing those 3 low-loading indicators.
This is just statistical criteria just to remove, but what about the theoretical justification?
That's fine too, because remember the original example about drunkenness? We said the reflective indicators are interchangeable. Okay, just because we're starting with 7 doesn't mean that we have to stick with 7. Because they're interchangeable, it's perfectly acceptable to remove some of them. Because, one variable could be doing the job of the other anyway. That's what we mean by interchangeable. So that's not an issue. Anyway, let me get on with this, and if there are further questions, we can stop again. Do you guys have the slides with you? Because I'm going to follow the sequence here, very much. I did update the slides today, so you might see slightly different comments here and there, but otherwise the main comments are the same. Okay, remember this is the initial testing, 10 formative indicators, 7 reflective indicators. We start by commenting on the reflective measurement model and specifically internal consistency. Now, internal consistency is essentially testing the correlations, if you like, between the interchangeable reflective indicators. The composite reliability here is 0.684. Now, I'm going to have lots of problems with this screen size. Here we go. If you switch to the PLS algorithm window, composite reliability is under the quality criteria. Click on that. It says 0.684. Yep, that's where you find that number. That's the reliability, internal consistency. I'm assuming you all guys are familiar with Cronbach alpha? Okay. Well, this is the preferred, composite reliability is the preferred measure that's equivalent to Cronbach alpha in PLS SEM. Okay, it's the preferred measure. Again, it's explained as to why it's preferred in practically all the references that I've given you in the attachments to the email. We can talk about that later if you like. Okay, indicator reliability, I'm following the slides here, is the next one to have a look at. And basically under indicator reliability, we're talking about how much the associated indicators have in common with the construct. Again, remember, we're still with the formative measurement model. We're still on this side, okay? I'm not saying anything about this yet. We're still on the reflective measurement model. Now, we have a range of loadings, which I've already pointed out at the beginning when I first generated this figure with the loadings. And I said, that one is quite low at 0.067. That's low, and that's low as well. Those are the 3 candidates for deletion or removal. Now, convergent validity, the third point on your slide, is looking at communality it's a bit of jargon, but communality of the construct, or the extent an indicator correlates positively with alternative indicators of the same construct. Okay? Now, the measure, the statistic, if you like, of relevance here is the average variance extracted. Now, let's go back to the algorithm. Average variance extracted, here we go. If I hover the mouse over there, it's 0.290. That suggests to me, that figure suggests to me that, excuse me, there's a relatively low convergent validity there. So that's not a good result. Okay? So let's keep that number in mind, because when we remove the 3 low-loading reflective indicators, we're hoping to see an improvement on that. Okay? We're hoping to see an improvement on that. Discriminant validity is essentially looking at how distinct is the construct from other constructs in the model. Again, we're looking at this construct, the endogenous construct, and under discriminant validity, we're posing the question, how different is this compared to the other 2? That's what we're doing. This takes us to the left-hand side, the formative measurement model. By the way, these are known as outer models. This is the inner model. The structural model is the inner model with those 3 circles. These are the outer models, reflective and formative. Again, if I can ask you guys to refer back to your slides under the heading of formative measurement model. Convergent validity. That sort of measures the extent, the domain of the formative construct is covered by the formative indicators. Now, path coefficients.
Sorry, we are lost. Which slide number is this actually?
10.
10, yeah, should be 10.
Yeah. Thank you.
Okay. Just make sure the heading is formative measurement model. Okay. So if you look at these 2 numbers, the path coefficients coming from the shadow banking, right? 0.587, 0.348. Now those are significant numbers. I don't mean high numbers. In fact, if you look at the literature in this field, those numbers will be classified as moderate. Not low, not high, but moderate. That's fine. We can live with that. Okay? Now, the next item under formative measurement model is multicollinearity or collinearity among the indicators. Now, again, there is a statistics that's generated by SmartPLS to help us make that judgment, and it's called VIF down here, collinearity statistic VIF. If I click on that, I see that the number is 3.044. Now, the rule of thumb here is, as long as it's less than 5, it's acceptable. Well, it is significantly less than 5, so we don't worry too much about this criterion at this stage. Are we okay? Yeah? All right. Now, next one, the so-called subheading, significance and relevance of outer weights. In other words, all these numbers. That can't be sort of judged based on the original run of the algorithm. You need to do bootstrapping here. Now let me just offer a quick introduction to bootstrapping as it's used here. There are many different types of bootstrapping, I'm sure, out there, but basically if we have, and we do, a sample size of 63, bootstrapping would randomly pick 63 banks to create a subsample. So the size of the original sample and the size of the subsample is the same. But the way bootstrapping chooses, selects, is random, which means a given bank could appear more than once in the subsample, in the bootstrapping subsample. The default setting in SmartPLS is 500 subsamples for bootstrapping. The literature recommends minimum 5,000. I've been working with 10,000. Okay? Again, I leave it up to you guys which number you choose in terms of the number of subsamples. So let me show you how to do the bootstrapping. Here we go. At the moment it's set to 500 by default. Let's change that to 10,000. It will take a couple of minutes, not too long. So start the calculation. And Terry, you can tell us a joke in the meantime if you like.
So how many years of data we have?
Just 1 year, yeah, yes. The data corresponds to 2013. It's only for 1 year. At the moment, we're in the middle of collecting additional data all the way back to 2004 in order to run the same model to see whether what we're observing is going to be stable over the years. We haven't got to that point yet.
But that still will be considered as a cross-section, or you have option of the panel or something?
I'm not sure whether PLS SEM allows a panel setup. My understanding is I'll be running PLS SEM separately for each year and observing whether I'm getting similar results or not. I don't mean just the R squared, but other criteria as well. Okay, guys, this is done now. The 10,000 subsample bootstrapping. Let's go back to the slides again on the formative measurement model. It says at 5% level, p-values following bootstrapping indicate that the outer weights, and outer weights are relative contributions, of 6 out of 10 formative indicators are insignificant. Well, how do I see that? Well, since we're talking about outer weights, let's find outer weights. Here we go at the bottom. Click on outer weights. And just expand this a bit. If I expand it, I'll lose the other half. These are the p-values. Yeah? It's just a matter of you checking against each of the formative indicators. Remember, the focus is at the moment on formative measurement model, not the reflective. And we've got 10 formative indicators. So check the p-values, figure out which ones are not significant according to the p-value, and see what can be done about this. The important warning that I put in the slide under this significance and relevance of outer weights is, I said at the bottom, eliminating formative indicators should be approached with caution because formative measurement theory expects the indicators to cover the domain of a construct. Go back to the example about drunkenness, drinking vodka, wine, scotch and all that. All of those indicators are important in determining how drunk the person is. You can't really remove them from the equation just because this bootstrapping technique is suggesting it's not significant. You've got to be careful about that. So this is one of those places where you have to stop and pause and think about whether it's a good idea to follow the statistics or whether you should allow the theory to override the statistics. Okay? In this case, we're allowing the theory to override the statistics. Okay? It just wouldn't make sense to drop 4 or 5 of the formative indicators. Okay, that's the bottom line there. This brings us to the structural model. Let's go back to that chart. So this is what I mean by the structural model, the 3 latent constructs there. And remember, these 2 from shallow vacuum are in fact acting as independent variables explaining the variance in the dependent variable. Exogenous constructs, endogenous constructs. 2 interchangeable terminology there. Okay, I'm on slide 11, the structural model. There is a red font there that says, if the outer models, that is measurement models, are not reliable, we can have little confidence in the inner model, structural model. So if these analyses that we've just completed on the reflective side and the formative side are signaling to us that there are some serious issues, then there is little point in proceeding with the analysis of the structural model in the middle. That's the warning there, anyway. Coefficient of determination, let's find that number. That's 0.801. We already knew this from the chart figure with the numbers. I mean, that's a good number in anyone's language. But like I said, at the moment we've got 3 reflective indicators that are loading quite low on the endogenous construct. So the idea is to create a more parsimonious model and still hopefully have a reasonable R-square value. The size and significance of the path coefficients. I don't think there's any major problems here. Let me see if I can find the... I need to go to bootstrapping for that. Path coefficients. So I'm on the bootstrapping window, path coefficients, and I can see the p-values. Now these p-values may not be exactly the same as we've got in the slides, because every time you run bootstrapping, it's going to give you slightly different intervals. You with me on that? Different confidence intervals. You're not going to get exactly the same confidence intervals with bootstrapping because it's random process, the way it selects the subsamples. Okay? So you might have a slightly different numbers in your slides, but don't worry about that, please. But this is where you find out what the p-values are in the bootstrapping window by clicking on path coefficients. Okay, well, basically, that's clearly significant. This is marginal at 5.7%. That's marginal. Next one is called predictive relevance, or Q-squared effect size. Now, for this, you have to do another test. So let me go to pull-down menu, find blindfolding. Okay, it's not accepting it at this moment. Let's go back to the chart. Calculate. Here we go. It's live now. Blindfolding. The so-called omission distance by default appears to be 7, but it's highlighted in red. The reason it's highlighted in red is it's signaling to you that that particular omission distance is not suitable given your sample size of 63. Again, there's a bit of an additional explanation in the notes that I've given you guys. So we're supposed, the rule of thumb is we're supposed to pick an omission distance between 5 and 10. So I'm going to work with 8, and I'm going to explain what I mean by omission distance in a moment. Let's run this calculation. It's called blindfolding. Blindfolding is essentially, in this case with an omission distance of 8, you remove the 8 observation and run the test. Then you remove the 16th observation and run the test. Then you remove the 24th observation, omission distance of 8, right? And rerun the test. That's what it is, essentially, in simple terms. So this is meant to generate so-called Q-squared effect size as well as F-squared. Let's have a look at those. First of all, Q-squared effect size. What is it? It's really the extent the exogenous constructs, and we've got 2 of those coming from shadow banking, are able to predict the data points for the reflective indicators. Q-squared is that number there, 0.175, which is also the number, I believe, in your slide. So that's good. It coincides with that number. Now, since this number is larger than 0, that's what we're looking for, then it suggests that the path models has predictive relevance. Okay, so that's a good number. It's not the best, but it's a good number. It's an acceptable number. F-squared which is assessing another effect size. These two are related. Q squared and F squared are related. And again, if anyone is interested in the formulas, I can afterwards tell you which reference to look up. It's again similar to Q squared, but F squared measures the importance of the exogenous constructs in explaining the endogenous construct. And we have 0.570 for the micro exogenous construct from the shadow banking, which is quite high, which tells me that if the micro, let me just go back to the chart. If this is left out, I'm talking about F squared, if this is left out, what would be the impact on the R squared? That's what F squared measures. So when I say to you the F squared for micro is 0.57 as opposed to 0.2 for the macro, what that tells me is omitting the micro has a greater impact on reducing the R squared value. In other words, it's more important in explaining the systemic risk in the regulated banking sector. So the micro is more important than the macro. Again, with our own partially simulated data. So that's the key message there. Okay, guys, at this stage, I'd like to omit those three variables, which were, and it's very easy, if you don't mind watching my mouse on the screen. Let me see. That goes. Total regulatory capital, that goes as well. Non-interest. Oh, this one. Okay. Now, all we've done at this stage is we removed three of those low-loading reflective indicators. And we're not touching any of those. We've already said that theory really expects us to maintain them because we want to be able to say we have covered the domain, okay, the domain of shadow banking that we have theorized to begin with here. And remember, these are meant to be complementary and these are interchangeable, two different concepts. So at this stage, I'm ready to rerun the tests. So I go to calculate, PLS algorithm, just leave the default settings, start calculation. Okay, going back to the slide 12, I think, under the reflective measurement model, we're following the same procedure again. Now what we see here is, if we click on composite reliability, it's now 0.784. What was it before? 0.684. All right? So it's gone from 0.684 to 0.784. So that's an improvement, no doubt about it. The second statistical criterion we're looking at is the indicator reliability. And again, probably the best way would be to bring up the chart again with the numbers on them. There's nothing under 0.5 here. That's looking pretty good to me. Convergent validity, that's going to take us to the AVE statistic. What was it before? It was 0.29. It's gone from 0.29 to 0.482. That's a fantastic improvement. Okay? So our more parsimonious model is doing better so far. It's doing better. Any questions? Yeah.
What is the cutoff value for the reliability indicator? Reliability, so 0.5 or 0.7?
Oh God, do I remember that? It's in the. Let me see.
I have a line here, that would be over 0.7.
I did give them to you guys, but this is indicator reliability.
Yeah. Yeah.
What's preferred is loadings greater than 0.7.
Yeah.
Is that a question? Okay, so far the internal consistency has improved. The indicator reliability looks fine too. Conversion validity has significantly improved. Discriminant validity is also better. The Fornell-Larker criterion was originally 0.538, now it's 0.695. Okay, so that's looking good as well. On the formative measurement model side of the exercise, convergent validity, the path coefficients are still moderate. There is no major improvement here as far as I can see. I'm talking about these two numbers, okay, 0.567 and 0.342, still moderate. It's neither here nor there. The multicollinearity that was originally 3.044, it's very close to the original number, so that's pretty much the same as well. So again, no issues or concerns with multicollinearity under the formative measurement model. Now, the significance and relevance of outer weights, again, we need to go back to running the bootstrapping to get to that. Anyway, while it's running in the background, just suffice it to say that there are some low outer weights, but when we look at the outer loadings, which are the absolute contributions rather than relative contributions, it looks a bit better. Gee, it's taking its time. In the old days, we were happy to put up for 12 hours for something like this to run. Now we don't wait for more than 15 seconds. Okay. What I might move on to is, by the way, R squared. Okay, to see R squared, we have to go for this. Is 0.756 now, so it did drop a bit, close to 5%. The predictive relevance, in other words, going back to Q squared and F squared, to get that we need to run the blindfolding, but I won't go down that road again. You've already seen that demo before. Basically, we see improvement in the p-values when we look at the size and the significance of the path coefficients. And the size effects or effect sizes are quite satisfactory as well. Let me see if I can go back to the slides too. Is there any questions before I shut down the SmartPLS? Are you guys sort of feeling a bit more familiar with how to run this? I think there is a student version that you can download. Yeah, that's what I mean. It's either a student version or trial version. I can't remember which. It's a student version? Okay. There would be some limitations in terms of sample size that it will accept. But, I mean, if you want to get yourselves more familiar with it, just download it and have a go. with your data sets.
Does you have a license for that?
Not that I know of. I mean, I have the full version here because the person behind the software is my co-author. Okay, but it's not a cheap software. Terry, how much was it? Was it $800 a year or something like that?
$800?
Yeah, it's not cheap. It's not cheap. It's not cheap. I mean, it would be nice at some point if there is enough interest. I can't be the only one putting my hand up, but if I get enough support from you guys as well, I can make a case to our IT group or to the head of school and say, can we get at least one license, full version, and then install it on one of the PCs, and you can sort of sit at that PC to do your testing. I mean, I can see that happening. The school is not going to pay for individual licenses, given how expensive it is, but that's one possibility. Yes, please.
How well known is this technique? So if you were to publish a paper using it, would you have to justify your use of it, or is it well enough known?
It depends on the discipline. Which cluster are you from? Tourism. I've seen examples from tourism, accounting, marketing, MIS. I mean, it's something that has become popular over the last 15 years or so. But hardcore covariance-based structural equation modeling fans would probably be more critical about it.
But at the same time, those guys don't meet all the criterias each time either. So this, I think you can make a case to try to get this because a lot of our data don't meet those criteria.
Absolutely, that was my starting comment at the beginning. Yeah, absolutely. So if anybody is really keen on applying this particular software to their research, I'm happy to receive an email from you. Make it as detailed as possible as to how you're going to use it, where you're going to use it, and I can mount a case for the school to get at least one license, install it on Common Access PC, and that's the way to go. I mean, you've got research funds, haven't you, Andre? You can spend your own funds.
Alternatively, Benjamin, you could put it in one of your lectures and use it as a teaching tool. Then you get the choir.
Not what I'm teaching now. Not what I'm teaching now. But I see your point, yeah. I see your point. Okay, any other questions before I hand over to Terry? How are we doing with time? Oh God, you only got 15 minutes. Sure, so.
I know that PLS doesn't take into consideration monofit, but covariance structural equation modeling focus on monofit. So how can
goodness of fit? Yes.
Yes. How when I get like let's say if I run PLS and I have all beautiful figures and results, but when I submit to the journal, they question about the error terms, the fit with the data.
You would be in trouble.
Yeah, I would be in trouble.
Okay, you would be in trouble. This is the opposite of covariance-based SEM, essentially. Okay, so the best way to tackle such Terry, why don't you come in? The best way to tackle such criticism is to make sure that your theory is sound. Okay, your theory is sound. Folks, I'm going to hand over to Terry before we entirely run out of time, because he's got a bit of a demo using the R language, which is free. Okay. Which one? What would you like me to launch?
Just the slides at the moment.
Slides. Oh God. Okay. Yeah. So you're not going to have time for the demo?
Oh, the demo will be 10 seconds. What I'm going to go through is how to set it up for R.
Okay. I mean, if there is no class after this, we'll have a bit of extra time.
So that shouldn't... Yep, that's it.
Okay. Off you go.
Okay, g'day. Many moons ago, I gave a
talk, last semester I gave a talk on R and the usefulness of the open source package R. In that, I spoke about covariance-based SEM, but I left out PLS. And the reason for that was it wasn't mature. It's now started to really grow. So when Neshme announced that he was going to give the SmartPLS talk, I thought, okay, you can't be smart without looking at the R. So I thought I'd whack some of the R concepts on there as well. So what have we got? Well, I grabbed Neshme's data, I grabbed his model, and just a little note down here that UQ Business School does not like people nicking stuff. And, this is the model. My esteemed colleague Neshme, just showed you the inner model, which is the structural, the measurement models here, which is the outer model. Now I've colour-coded these to help us encode it within R. The package I'm going to be using within R, see, R is a generic package, and then you can add modules to it, or libraries to it. The library I'm going to add is the, just show you the code, is the PLS SEM library. So all you need to do is download the PLS SEM library, and then you'll be able to run it. And that's all the code that we need to set up and run our PLS. I'm going the wrong direction, as usual. Okay, so there's the models. We need to build the inner model, so the structural model. So what we've got is, I'm less wordy than Neshme because I can't type quickly. So I've simplified it to micro, macro and RBS. And the micro and the macro feed into the RBS. So I've made a variable called micro, and it contains 3 elements. Macro, 3 elements, and RBS, 3 elements. I combine those into a matrix called path. Now the way to read this is you say, well, what is feeding into? What latent constructs are feeding into micro? Nothing. So I set my micro up as to all zeros. I've got 3 because I've got 3. What feeds into macro? Nothing feeds into macro. There is no latent constructs feeding into here, so 0, 0, 0. But RBS has both micro and macro feeding into it. So micro feeds into RBS, macro feeds into RBS, but RBS doesn't feed into itself. And then we combine the micro, the macro and the RBS together as a matrix, and this is what we have down here. So the way to read this is to say that the columns feed into the rows. So micro doesn't feed into micro, micro doesn't feed into macro, but micro does feed into RBS. So you can do it in that way. Now, just to make sure that you've got it right, you can do an inner plot of that path. And when you do the inner plot of the path, you get this diagram here, and you go, yep, micro is feeding into RBS, macro is feeding into RBS, and nothing's feeding into those. Notice how this is loaded, though, down the bottom. If you don't do that, you can have, if you don't do that, then you're going to get an error. So you can have various connections along here, and they're all specified as 0 for no connection, 1 for a connection. But as long as the bottom one has the most connections, it'll work. I suspect there's an LU solve going on here because it complains about a lower triangular matrix if you don't do it that way. But let's move on. Let's set up the data. So here's my path that I set up. It's a matrix based on the micro, the macro and the RBS. So that's all my connectivity here. Down here is my Excel data sheet. And what I've done is I've said, well, these yellow variables connect into micro here.
Terry, what's the type of the Excel file? CSV?
It could be CSV.
Doesn't matter?
It doesn't matter. I've loaded in, you can load in your standard XLSX file if you like. The R code will tell you, you put in some R code to read the file. I'll show you how that works in a minute. Good question. So that is the 4 variables that, sorry, I'll learn to count one year. That is 5 variables that feed into micro. These white background ones here are those there of my Excel spreadsheet that feed into macro. And then my reflective variables here come from RBS, and I've coloured those background green. So what I now need to do is to associate these blocks of variables with their latent measure. So, because micro comes first in the path, in our path listing, I have to use micro, and micro is the yellow. So that's 1, 2, 3, 4, 5. So it starts at column 5, 6, 7, 8, 9, goes to column 9. Then macro is down here at the end, and it starts at column 10 and goes to column 14. Then finally my formative data here from RBS goes from column 1 to column 4.
You mean reflective?
Oh, did I say?
You said formative.
Oh, shoot me. I mean reflective. Thank you, kind sir. I'll make sure I run fast. So basically my Excel spreadsheet is out of order, which is why this is out of order. Right. Now, the default for the PLS PM is in fact reflective, or what it calls type A. So now we have to label our micro as being formative, type B, our macro as being formative, type B, and our RBS as being reflective, type A. And that's practically it set up.
Sorry, Terry, in terms of A's and B's, is that the notation you came up with, or it's...
No, that's the PLS PM's notation.
Okay, well.
Yeah, I wish I'd pick something a bit easier, like R and F.
So Terry, about these sort of coding that you have done,
Yes.
you should be able to find all this information on the internet, how to write it.
Oh, absolutely. Absolutely. There's lots of documents, nice thick documents that describe how it works, what it does. There's lots of examples in the library itself. So you can pull down on the... So when you use that library, you could say, there's a data command which allow us to use some data that's in the library, and code and everything is there as well. So there's lots and lots and lots of examples.
Terry might like to give a bit more good news to Osman. He was able to pretty much come up with the same results as I did in SmartPLS using mine.
Yeah. Yes. So the code is quickly. This clears everything from memory, loads a library. This code here, and I tell a lie. You could read in your Excel file if you wanted to, but I actually read in a CSV file. Then we do setting up the paths. Check the path, just eyeball it, see it's right. Set up my data. And this here, Nedge PLS, oh, bother. This Nedge PLS here is where I'm actually doing it. I run the command PLS PM. It takes in my data, which I've read from the file. It takes in my path that I've generated. And it takes in my data blocks. And we set the mode to latent modes. So we've got latent variables here. And then the data crunching happens and it all falls into a structure called Nedge PLS. And then we can plot it, get the summary of it, and do all sorts of other stuff. So let us now jump on to the SmartPLS R code. So I've got some R code here called It's the Code, and that's not associated with RStudio. RStudio is not R. What it is an IDE that allows us to work with our R files.
What's ID?
Oh, Integrated Development Environment.
Thank you.
Oh, sorry, I'm so used to delivering IS lectures.
In English, please.
English,
Probably just figured out the code.
So here is the code. Here is where R lives. Here is an environment and it's empty. So what I do is I select the code or go Control A, then I run it. Now in my code I've told it to ask me where the file is. There's the data file. Yes, where my data file is. So there's my data file. Let's slurp that up. And it does all the calculations for me that quickly.
So that way you can have your data file residing in any folder.
Yes.
As long as it prompts you for it, you can then go to the folder. And
Yes,
pick it up.
yes. And that's just, well, the way that I've set up my R.
Okay, that's a good way.
Okay, now before discussing this, what it does is it gives you various diagrams with weights and loadings, and those are in the slides. But that's my path as I've set it up. No data on column 8, yes, it loves me. My latent modes is whether it's formative or not. So, I'm sorry I'm sort of rushing to get within time.
Yeah, the echo recording will stop in 2 minutes.
Okay, right, DocCam left. DocCam right. No, there's two DocCam lefts. Oh no, there's a DocCam right. Oh, DocCam. Now, what I did earlier was I went through the summary data and let's see if you can see that. Oh, heck, you can. Okay, and the black is Neshme's, the red is R's. So black is SmartPLS, red is R. And the numbers are very close.
We can't read your handwriting.
Gee, you wouldn't be the only one. So basically 0.757 is the R squared, 0.544 as opposed to 0.529, 0.854.
And what's the black number there?
The black number where?
Corresponding to 0.854.
It is 0.849.
Okay.
So it's very close, and if you look at all the other numbers here, they're very close. The AVE given to you
Is identical.
is identical. There isn't yet a Q-squared measure that it has. It does provide you with HDMI. Come back, all is forgiven. Come on. Back. Okay. So, now, let's go back to this. So, that's the code. Basically, put the library in, get your file, set up your path, set up your data, and then run the analysis. Very simple. So here is the model that we're working with. Now, I didn't use bootstrapping, but I could have. And the default for this was Centroid, and that may be why our numbers, Neshme, are slightly different, because you didn't use Centroid as your weighting scheme. And it gives you pages and pages of data, all with weights and loadings and t-values.
Are the headings somewhat similar to what we went through with SmartPLS?
Yes, somewhat similar. You'll be able to match it up fairly easily. Here's a goodness of fit measure of 0.5817. Now, the goodness of fit measure, because we've got formative measures, I would not take that as being a very good measure, because it takes the communalities into account too much.
There was no goodness of fit for PLS SEM, isn't there?
There's lots of attempts, there's lots of versions of it. This is just one version of it. But there's no definitive one, no. Part of those plots that we get in our studio are here. The micro connects to RBS 0.5592, macro 0.3513, again very similar to what Neshme had. Now, because we've got formative and we've got reflective, it means that we have to, because we've got formative and reflective, it means that we have to take, for coming into RBS, we have to take the loadings, and we have to take the weightings for micro and macro. So, for formative, you take the weights. For reflective, you take the loadings. Now, the direction of the arrows give you a lot of the information. The red here means that it is just highlighting that it's a negative value. But these numbers are very similar to what Neshme had with his SmartPLS. I know I've rushed through this fairly quickly, but if you draw out your diagram on a piece of paper before you set it up, it's then easy to set up the path, and then it's just a matter of saying, well, this is where my data is in the spreadsheet, so these are the blocks of data associated with each latent variable. Put it all together, and it comes out free of charge. Always a good thing. Thank you. Any questions? Yeah.
Similar to the question, which one's more acceptable at the moment? It depends on
Well, yeah, look, SmartPLS is known, right? R is known. Professional statisticians use it. It is very well trusted.
Can I answer it this way? So the SmartPLS is the best known compression package.
Yes.
Whether it's any better than what Terry has shown us.
And I think on top of that, yeah, on top of that, because it's adaptability to different platforms, and even being able to connect with different libraries and plugins, it makes it much more powerful tool than any
If
other.
you're comfortable with
Absolutely.
it, by all means, yeah, go with it. I'll do it, but I'm not. I'll have to point and click.
All I just don't know is it compatible with Mac?
Yes,
It is.
it is compatible with Mac, it's compatible with FreeBSD, it's compatible with Linux, it's compatible with Windows, all versions. Oh, not Windows 95, but that's not really a version. It's a graphical interface around DOS. But, yeah, so R is very, very portable across multiple operating systems.
Anyway, if anyone's sort of working on a paper and they need to write PLS SEM, need to include SmartPLS. I'm sure Terry
Yeah,
will be quite happy to as well.
I share your sentiment.
His expertise on R.
Nish May will help everybody with R, that's fine. No, of course I'll help.
That's great. Thank you.
No, it's okay. I mean, we probably still have time till 4 o'clock, but the recording has stopped.
Thank you, Rich.
That's okay, mate.
I really appreciate it.
No problem. Okay, keep in touch.
But yeah, as I said, I mean, you could include that in a lecture, 2-hour lecture, right?
I'm still learning myself.
Yeah, no,
I'm new to the technique.
Absolutely.
I'm new to the technique. I don't know everything.
As I said, that was very helpful just to see how it's used and how you use it.
I like yourself. I mean, I look at the real world data, and it's hardly ever normally distributed, which means, the traditional SEM is going to have lots of problems with it. You're making a lot of assumptions using SEM.
Thank you, Nish.
That's okay. That's okay.
It was useful.
Okay.
Thank you, Nashmi, for the session.
That's okay,
Thanks a
Esma.
lot.
Okay, see you guys on
Thanks,
Tuesday.
Terry. Thank you.
Thanks for that, Nish. Very
That's okay. My pleasure.
So you said